Computer. Hello, today is session number 5, where we will look at some examples of coding interview questions, and this will be the last one. So you see the list of the questions. First one is the famous two-egg problem. So building has 100 floors, you have 2 eggs. Find the highest floor from which the egg can be dropped without breaking. Okay, so the idea is to use the first egg to make big steps to quickly find the breaking height approximately, and then we use second egg to do 1 floor increments to find the exact floor. So suppose the first egg, we always skip 5 floors, right? So we dropped it from 5th floor, it didn't break, then 10, then 15, whatever. At some point it breaks, then we, second egg, we start from the previous step. So let's say it broke at, I don't know, at 100 exactly. So we made 20 steps. So then the second, we drop at, what, it's 96, 97, 98, 99. So maximum 4 steps for the second egg. So maximum total 24 steps, right? So the question is, can we do it in less steps? The answer is yes, we can do it in 14 steps. But then the trick is that we change the size of the step. So the first step we make n, the next step we make n minus 1, and so on. And together it should be 100, so we need to estimate the n. So the n happened to be 13 point something, so we make it 14. So we go through the series 14, 27, 39, and so on. So here it's 14, it's 14 step. Next is 13 between 14 and 27, and so on. So we're decreasing. So here are different scenarios, different positions, how we can like do maximum of 14 steps. Okay, so this is a famous problem. My son actually got this problem on his interview at Google at some point. Second largest item in binary search tree. Okay, so you need to write a function to find not the largest. The largest would be the rightmost, right? So for example, in this tree, the rightmost is 12. But the second largest, it may be the parent of this largest, or it may be the largest in the subtree. So it's either this or this. So you need to try both ways and compare. And this code is doing this. So complexity is big O of the height of the tree, and height usually is about logarithm. If it's balanced, then it's about logarithm of the total number of elements in the tree. Okay, so next one is simulate a 7-sided die using 5-sided die. So you have a 5-sided die. So how you do that? Well, it's actually very simple. There is a whole class of problems like that. And the idea is that we roll 2 dice, 2, how you say, die, I guess. We roll dice twice. Let's put it like this. Okay, total number of combinations will be 5 of the first one and 5 of the second one, so 25 combinations. They all equally probable. So if we hit a position between, we number them from 1 to 25. If we hit position between 1 and 21, so it can be divided by 7 and we get the number, right? And this will be the output of our function. And we convert it. Okay, if we hit position 22 to 25, we simply re-roll. So here's the code. So this is the simple implementation of the rand5 function, right? So in Python, random has a random range from 1 to 6. That means that it will be 1, 2, 3, 4, 5. And they're all equally probable. So here we do one roll, we do another roll, we combine them. So first roll by 5 plus the second one plus 1. So here we might do -1 to get it starting from 0, right? We need it because if you want to get like 1, 2, 3, 4, whatever from here, this should be 0. Anyway, so if outcome is more than 21, we do reroll. So we simply continue and repeat the cycle. And if it is within 21, we divide by return outcome by 7, no, by 3, right? Yes, like this. Okay, so this is solution for this problem. Okay, implement a queue with 2 stacks. I don't know, for some reason I've seen this problem multiple times, although it's quite trivial. So I will not even code it, I just explain like the logic. So we suppose that we already have some sort of implementation of a stack. It may be as simple as a list, and it has 2 operations, push and pop. So we start putting stuff into stack 1. As soon as we get first dequeue request, which is a pop request, we move all from stack 1 to stack 2. So we do it one by one, right? And then we now in stack 2, they're in reverse order, and you start popping them to return and accept the input into stack 1. So, okay, and then when stack 2 get emptied, you can again move whatever you have in stack 1 to stack 2 and continue. Okay, so this is this problem. The stolen breakfast drone. Okay, there's a whole story, like Amazon decided to deliver breakfast by drones. Each drone has ID, and we have records of the departure and return of each drone with their IDs. And then one drone was stolen, and you need to find which drone was stolen. And the idea of the solution is to use XOR operation. So XOR is very powerful because if you apply it twice, like if you do A XOR A, it is the same as no operation. And it doesn't matter in which order the elements are in the record. So here, for example, we have A, B, C, D, E, A, B, C, D, whatever. And you can regroup it as AA, BB, CC, DD, and all these pairs equivalent to 0. So you end up with E, and E is the only one which doesn't have a pair. So it's just a binary XOR operation applied to numeric IDs, integer IDs. Yeah, it says integer IDs. So again, very elegant solution, just to know properties of how XOR operation works. Okay, reverse a string in place. Again, very simple. How you do that? Well, here's the key. You convert a string into a list of characters. And then starting from outside, so you get left index is the very beginning and right index is very end. And then you simply start swapping them. You see left index, right index equal, and the opposite, right index, left index. And then we move left index to the right and right index to the left. So they go to the center, and eventually, after they all swapped, you just return join of this list. Okay, so this is a simple problem. Next one, sort positive integers in linear time if values are limited. I mean, this is really cute because usually when people ask you what's the complexity of a sort, well, it's n logarithm n. Sometimes it may be worse. It depends on the method you're using, but the ballpark is n log n. But if all the numbers are limited from above by some integer, then we can do it in linear time. It's like really interesting. So what we do, we generate a buffer filled with zeros, and the length will be the maximum value, which is possible. Then for each element in our array, we put it in the index in this buffer, which is equal to the value. So if all the values, for example, are less than 1,000, So we make a buffer of size 1000, and then we get a number. Let's say number is 5. We put it on the 5th place, and then if this array we have another number 5, it will get also in the same place. So what will happen in the buffer? We increase the value. So we put one time, it will be 1. We put second time, it will be 2, and so on. Okay, so we do that. We populate the buffer, and then we create second array. We're starting like populating it all with zeros, and the length is the length of the original array. And then we go through the buffer, and if it is value not 0, so if it's something there, we append to this R2, like and continue. So yeah, it does it. The result is that all elements will be sorted because they were placed in the buffer. Apparently, they're sorted. They just sparse with some zeros between them, but they're sorted. Okay, next, in-place shuffle. Do an in-place shuffle of an array of numbers. It may be uniform, same probability. Assume that we have a function from floor to ceiling. Actually, we'll be using random range, like from Python random library for that. And the solution is very simple. It's called Fisher-Yates shuffle or Knuth shuffle. And here it is. And the idea is that so this is the length of the list. And we go through the length and we swapping the elements as we go. Yeah, actually nice maybe to pause and go over why it is providing a random distribution, but I actually haven't prepared this analysis, so let's skip it for now. Okay, find duplicate at least one in an array with minimum space. Okay, this is a tricky problem. First time I found it and I was trying to solve it and realize like the solution is elegant, but you have to fit this 0, 1 space request. Because normally to find the duplicate, you can just use set or dictionary, whatever, boom, done, like in one line. Okay, how we do it? We convert array of numbers into a linked list. So here you have a linked list. So each element of array has index and value. And the way we build the list is that the value in the node is the value from the array. And next points to the element with the valueth index in the original array. Okay? So interesting. So if we draw a linked list diagram, we will find the duplicate point to the same node. So we'll have a loop with a rope. So here on the right, you see example of what we may have. And then we use a famous approach, which is rabbit and turtle, to find the loop and figure out its length, right? And once we know the length of the loop, then we start two turtles. So they go, remember, rabbit skips the step and turtle doesn't skip the step. So we start two turtles, and as they go through the loop, like the first, and they are L apart, where L is the length. And so when the first turtle will enter the loop, go, and then it meet the second turtle. So we know that this is the point where the loop starts, and this is the duplicate. So this is kind of a convoluted solution, and you only need it because of this requirement that it should be big O of 1 for space. So you should not use a lot of space. Okay, next is graph coloring. So you need to color the nodes in a graph so that adjacent nodes have different colors. Okay, so given a unidirectional graph with maximum degree D, max number of connections for a given node. Okay, find a graph coloring. using at most D+1 colors, do it in linear time and space, and check edge cases as usual, nodes with no edges, cycles, loops, and so on. So this is the solution. The solution is very, very trivial. We just go through the nodes and if a color already taken, so we put a set, right? Again, it's not anything difficult, quite trivial. So I'll just go to the next one. Mesh message. Okay, and again, we will not analyze the solution in detail. I leave you as a homework, but here is the problem. Mesh message app sends messages through a mesh of users. Given information about active users of the network, find the shortest route for a message from one user, the sender, to another, the recipient, and return a list of users that make up this route. So, for example, we have a network, and these are, I guess, the names, right? And for each name, these are the names they are connected to, right? So these are the connections. For the network above, a message from Jaden to Adam should have this route: Jaden, Amelia, Adam. So we start with Jaden, then go to Amelia, and from Amelia, we can go to Adam, right? And this would be the shortest route. So we need to find the shortest path in the graph of users. And so suppose the graph is undirected and unweighted, we will use breadth first search using a queue. And we already spoke about the difference between deep first search and breadth first search. When we go deep, it's recursion. When we go breadth first, we're using a queue. So making a queue is like a list of the next steps, and then as you go, you add to the end of the queue. Okay, so this is the solution, right? And again, I will not go through the code. You can go through it yourself. It's not difficult. Final slide is when I was preparing to different interviews, I went through multiple websites, and I just realized something is missing here. So the very famous one is LeetCode, and I still keep paid subscription to it. There are literally, well, hundreds, actually more than 1,000. I don't know, like what's the latest count, how many problems they have. And you can look at other solutions in different languages and see and try. This is amazing resource. HackerRank also similar, and you get on their list and they start sending you problems regularly. So if you're just being with them and participating in these problems, really helpful. Interview Cake, similar. They have also, they all have paid programs. So, and I actually paid money to all of them. Interview Cake, like a really good set of problems and like typical problems. Educative, amazing resource. I highly recommend. Yeah, I took several of their courses, paid money for them. Really good stuff. Gurav Sen, this is a genius. He's on YouTube. He has a lot of tutorials, a lot of free videos, and also paid courses. I didn't buy his paid courses, but I really enjoyed his explanations of quite complicated concepts. So I do highly recommend him. There are some good books. I already gave this list at the very beginning of this whole series. One thing which is missing here, I will add to the slide, is Tech Lead. So Tech Lead is former Google, former Facebook software developer, Tech Lead, high level, who now is a famous YouTuber, and he has different tutorials. He has a course, I think, for $100 called Code Pro with 100 problems, similar to ones you see here. and he has a more like a bigger one for like $500. So yeah, it's a good quality information, definitely. So this is more than enough for you to prepare to any algorithmic interview. Of course, there are many other YouTube channels, but this is definitely covering the basics. Okay, let me stop the recording.